Hello, everyone. Welcome back to Bite Size Wisdom, where we break down complex tech topics into simple, digestible bites. I'm Saravanan Dandapani, and as promised in my previous video, in this episode, we will learn about the basic statistics required to master AI. In this episode, we will learn about the importance of statistics, and we will dive deep into six different statistical concepts. Now, I know statistics might sound intimidating to some, but don't worry. I will walk you through core concepts every aspiring AI engineer must understand using analogies you can relate to. So let's get started. Let's begin with mean. It's the statistical term for the word average. Imagine there are seven students and their exam scores are 40, 45, 50, 60, 60, 75, and 90. To find the mean, you add up all the numbers and divide by the count, which is 7. So the average is 420 by 7, which is 60. The mean gives you the fair share or the central tendency. In AI, we often use the mean to understand the average value of a dataset, such as the average height of the people, average salary, average number, and the hours worked, and so on. Next is median. Again, it is a complex sounding statistical name for the middle value in a dataset. Here is how you find it. First, you sort the data, then pick the middle value if there is an odd number. If you have an even number of data elements, just average the two middle values. Looking at our example, we have 7 elements. The data is already sorted in ascending order. The middle value or the median value is 60. Median is extremely useful when there are outliers in the data. Again, outliers is another complex term to identify an extremely high or low value in a dataset. The presence of an outlier may skew your mean value. That's where median comes to your rescue. Median avoids being distorted by extreme values or the outliers. Next is mode. It is a statistical term for the most frequently occurring value in your dataset. Looking at our dataset, the mode will be 60. In a machine learning classification problem, the mode is important value when models predict categories. If you want to know which class is predicted more often, we look at the mode value. And of course, there is no special formula to compute mode. Two important statistical concepts we need to learn to master ML and AI is bias and variance. Let's start with bias. In simple terms, I would like to call bias as off-centeredness of predictions. Imagine you are playing darts. If you keep throwing darts and they all land in the same wrong spot far from the bullseye, that's high bias. It means your aim is consistently off. You are making the same mistake over and over again. In machine learning, bias refers to the error that arises from using an overly simplified model that cannot capture the underlying patterns in the data. It's like a model trained to recognize cats, but it only pays attention to the shape of the ears. It may be okay with some cats, but it will likely call a fox or a dog a cat as well. Your model is making systematic errors. It has learned a pattern, but just the wrong ones. So, when we say a model has high bias, we mean its predictions are not spread out, but they are centered around the wrong place. The model is not flexible enough to capture the real structure in the data. This leads to what is called underfitting. In machine learning language, it means poor performance on the test data. So bias is about how far of the average prediction is from the correct answer. Next, let's talk about variance. Picture the same dartboard. This time your darts are flying all over the place, left, right, up, down, and some hit the bullseye and some might miss the board entirely. That is high variance. In machine learning, high variance means your model is too flexible. It memorizes the training data, including all the noise and quirks, but completely falls apart when shown new unseen data. In other words, a high variance model is very flexible. It fits the training data almost perfectly, but does not generalize well to unseen data. That is called overfitting in machine learning terminology. One of the central challenges in machine learning is balancing bias and variance, also referred to as bias variance trade off. Finally, let's talk about correlation, which measures how two variables are related to each other. A positive correlation between two variables means as one variable increases, the other variable increases as well. For example, the longer we work out, the better our health is. So, exercise and health have a positive correlation. A negative correlation means when one variable increases, the other variable decreases in its value. For example, eating more unhealthy food, the worse our health will be. So, junk food and health have a negative correlation. So, correlation measures the strength and direction of a linear relationship between two variables. In machine learning, correlation helps us detect patterns and choose the right features that are useful and avoid redundant variables, which eventually help in building simpler and more reliable models. That concludes this video. I hope you enjoyed it. Let's meet again in my next video where I will talk about the basic math you need to know before learning AI.